guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. This will be the right place to bring you guys in on this one. So what we're looking at now is yet another kenwood. Don't get this one confused with the one that's up for sale right now, although this one will be up for sale also. This is a TL922A hardcore box. I wanted you guys to see the bottom side of this thing. This is so much more ornately and beautifully put together than an SP220, but all the same fundamentals are still here present. You can have your filament inputs, your RF input's going to be in the same place. Somebody has gone through pre-me and grounded the grids on this thing already, and that was the main reason I flipped this over. That, and I wanted to get the part number off of this transformer right here. I got to take a picture of this guy because I got to get another one of these built. So I got to get all the dimensions off of this too. But what I wanted to do is I wanted to look at it. This is an unknown. Okay, we don't know if this amp works or not. We were led to the conclusion or the possibility that it does not work. So I've got to give it a really good thorough once over. This is your output band switch. This is your input band switch. These are pretty hard to come by, but they're in a whole lot better place and they're a whole lot more supported than on an SP220. This would be more like on the classic style with a drag. The downside with this is there is no ventilation that takes place on the pins. Now, this is our bottom panel. This is our bottom panel. That's our ventilation source. So it's going to draw air in through here a little bit, but not like what would happen if you put a couple pegs on your feet and set the thing up about this far off your bench and then had a little muffin fan that was just blowing air up on the bottom of the pins. You get much longer transmission out of this thing. Now, the other thing I did with the other kenwood last night is I sat there and I went through every single 3500Z tube that has been sent here, which is I think a total of 8 or 9. I have 2 very good matched tubes that are going to go in this thing. So, yeah. And for a couple $100 more, we'll send you a brand new set of tubes with the amplifier. But this thing is going to go for sale. This thing is really nice. Now, what you might have caught on the kenwood amplifier video from last night is when I went to this position, the needle didn't move. And also the power meter position was off. That's because there's an adjustment for the ALC, and then there's an adjustment on the top side over here, on the top back side, to where you thread these caps off. And this one here is your power meter adjustment. Or ALC, pardon me, and the power meter adjustments on the top. So all I have to do is demonstrate the meter moving, and from there you can make it as accurate as you want. So this is your input tuner section. How pretty that is. Internally, this thing is a solid 10 as far as its looks and aesthetics. Solid 10. There's a couple little scratches here on the bottom. A little scratch on the side, another little scratch over here. Faceplate is pristine, and the bottom panel does have a rub mark on it right here, and another couple of really slight rub marks up here in the front, but you'd never know because that's facing down. The down problem for this is there's this scuff mark here, but I'm going to see if I can get that to come out. So we'll come back to the beautification of this here in a minute. Let me flip this puppy over, and I want to see what it does. But I'm going to have to run this without the tins on it. I got to check filament volt, bias flop, all that kind of stuff. This thing is pretty. Very impressed with old kenwood here. And guess what? I got yet another one that's here for repair. And another one on top of that that's here for repair. So the little 3500Z is becoming my bitch. I'm totally fine with that, by the way. I love the 3500Z. I think it's a great tube. So let me flip this over. Let's go look at the top side. Okay, so we pulled the top cover off. This is mint. That isn't stock. That doesn't. It's a tiny screw. That doesn't matter. This thing's mint. I don't see anything in here that's going to give me any reservations. Now, it has been remetered because this is definitely not stock here. And the way these work is these fuses are actually supposed to hang down. So, all right. This one's currently wired for 110, which means that yes, it's going to go on a variac as we bring it on, because I want to really watch and see what this one does. So, give me a hot popcorn dog minute. We'll take a look at it. Let's try this again. 45, 50 volts. High voltage is lagging way behind. We got no light. So let me do a quick little test here. Is all the bulbs burned out? Or is it that the filament transformer in this one too is shotched to shit? Grab it there and then we'll go out and grab the common ground. See, if memory serves me, these work on an 8-volt filament transformer, or 8-volt lights. Yeah, I'm not digging this buzzing noise. Okay. It's not resisting me too hard on the variable step. We got filament volts. I mean, we got high volts, but we ain't got no filament yet. We have problems. Okay. So now I measured everything, and I brought the variac all the way up to 110 volts, and I was getting 4.5 volts at the lights on the front, and I was only getting about 2.5 volts on the filament. And I'm like, man, it sure seems like this thing isn't wired properly. So I thought, you know, I've seen things act like this before when you got them on a 110 volt plug, like this here. I'm not saying that this is all the problem, but this could definitely be most of the problem. I just don't see anything blown up, burn up, letting the smoke out. So I go and I look, and I pull off this sheet. This is a back access panel to modify it to go from 110 to 220 volts. So it's calling for a jumper between pin 1 and pin 2, pin 5, pin 6, pin 7, pin 8. But what we actually have going on here is a jumper between, nothing between 110 there, pin 1 and pin 2. It looks like it, but this is a blank empty hole. So this thing is currently, if I'm not mistaken, wire for 220. But it's on 110 volt outlet. So now I wonder, just wonder, what happens if we move some jumpers around? Let's see what happens here. We'll find out together. Let's get in here with our highly conductive hemostats and make sure we got an electrode attached directly to our foreskin. And let's take this off. Take this off. Just, I've seen Hibben and Hahn like this before. And so I was like, well, I have a feeling. I just have a feeling. So, let's, very quickly with these jumpers. This is what you get by assuming. Before I even started, I should have pulled this panel off and looked. Should have pulled the panel off and taken a quick look for her. Another big clue was the fan. The fan's a 110 volt fan, right? Fan wasn't even turning on. So it tells me that there was no power getting to that section of the amplifier through the switch. So, well, we converted it over for 110 volt use. So let's go ahead and button this back up. Let's give it a run. Okay. Now, if nothing has blown up smoke, chooched, or let out the smoke, when we first bring this on, there's going to be a contactor in the back that we're going to hear buzz and then click into place. And that's part of the high voltage circuit for the transformer. So we're going to hear it buzzing as the coil starts to come on, so we're not going to pause too awful long as we bring the voltage up. But here we can see very clearly what our plate volts are going to be. We're also going to see if there's lights that are going to illuminate. That's going to tell us if our filament is good. Air parentheses. Got this hooked up to our 10-to-1 reduction probe, and in the background we got our variac, so you can sit here and watch me twist the knob. So, I remember this from yesterday because it's kind of like deja vu. I went through this whole process just yesterday alone. So, let's see what happens here as I bring this up. Ready? Go. Here comes our high voltage. .800 volts, about 1,000 displayed. Contactors engaged at 80 volts. And 1,500 volts out of the power supply. We got good meter light here, got light here, and I'm seeing light come through the windows here. Let's go ahead and bring this on up. Fan is moving, and now we're at 110 volts on the input, 2,130 volts on the plate. Go to high volt setting, 3,000 volts on the high volt setting, 3,198 volts. We'll go ahead and bring it on up to the 220 volts or 210 volts on my line output, so we're 2,300 volts. Back that on down to about 215 or 115. Good contact. This looks good. I don't think we're going to have a problem here, not one bit. Bleeders are nice and smooth. So it's supposedly showing 10 volts, but it wonders quite a bit with the 10-to-1 reduction probe. Here, let me go to ground. Probe's on ground. So it means the leads are technically shorted together and it's still showing us 0.01. Or yeah, 0.010. So it means we got no AC leakage. None, not even a hint of it. Cool, on to the next step. Okay, so here we are at the bench 2 pill. 2950, driving a bench 2 pill. Now, what we got going on here is a 1,000 watt slug in peak, 1,000 in average, and a 5 watt slug in reverse. Back from the Bird 10,000 watt dummy load. What I want to show you here real quick is what we're going to put into this Kenwood for drive. About 210 watts. That's all we're going to put into this thing. Now, let's go over here and establish our baseline. We got our power on switch, and we are in high mode, so we're putting about 3,000 volts on the plate. Our operate standby button, RF meter, and so on. This thing has been Mars modded already. It means the physical lockout stop for the 28 megahertz band has been removed. Now, unlike the one that we did a video of just last night, it had 28 marked on there. This does not. Okay. It's at the 28 megahertz index at 6. So now what we got in here is a pair of iMac tubes. They're older. They're still 100% output. That's what's in there. So now, step on a foot pedal. Beautiful red. Burying it in the corner with 200 watts of drive. So, we'll go on up to the 2x position. So now full deflection over there on the 100 watt scale is, well, 2,000 watts. Burying it in the corner. Still at only about half amp, which is what you want. Now remember, we're only on 110. So this thing will perform even better on 220, but it's currently wired for 110. 110. And believe me when I tell you that distribution block there that has been radically modified on the inside. There's only about 2 things that are actually plugged into all of those outlets that are running right now. One of which is that TV. So, so now we're looking at that middle scale. 2,500 watts on 110 with 220 watts of drive. So that means on 110 with 100 watts of drive, you're going to get about 1,600 watts out of this box. Otherwise, full legal limit. The reason I got this plastic fan sitting up here blowing air on them tubes is without the body armor on it, and I explained that in the video last night, these tubes get incredibly hot. The way this works is it draws air in from here, and it draws air in from underneath, and it draws air in from over here on this grill work, and it all circulates through the cabinet, spinning air around the tube. And that's how the system of cooling works. Without the lid, and without the body armor on top and bottom, the air circulation isn't right. And being what these iMac tubes cost now, I mean, we got spares here, but I don't want to go and burn them down just for a video. So, on that note, I want to show you that the RF power meter is working, but you adjust it on your meter on your scale on the other end. I don't know how you want to go about reading that, if that's going to be 4,000, 3,000, 2,000. We need to adjust these knobs, just like I explained. Okay? And this IG button should be dead because we don't have... Okay, so the AGC control needs to be adjusted. That's it. All the lights are working, as you can clearly see. That's it. I think I'm done here. Set the plate voltage back on down. We'll go ahead and shut this off. Now remember, these have got a little timer in them for the fan in the back, so that will keep running for a minute. Now guys, everything taken into consideration that we've got going on here. A couple little scuffs on the outside. I was able to get the scuff off the lid. That looks mint. You'll see it in the pictures here in just a minute. I think we're pretty happy. We'd be about $1,350 plus the ride. But on a scale of 1 to 10, this is probably a 9.5. And the 9.5 comes from the little tiny scuff marks that are on the sides. It's like that little tiny nick there, and those 2 tiny little rubs. I think there's a couple others. There's a few rubs on the bottom I pointed out in the previous section of this video. So if anybody out there in radio land wants themselves 160 meters, here we go, 160 meters through 10 meters, Kenwood, TL922A, give this number a call, and we'll get it out to you just in time for Christmas. Gentlemen, my name is BBI, and without a shadow of a doubt, I am the biggest mud duck out here in a great, beautiful state of Idaho. And I am very lucky and blessed to get all of these little projects to work on. Now, the other two that I have left that I need to do, one's a customer, well, they're both customers, but one's been waiting for quite some time, and I'm going to jump onto his amplifier here right after this X-Force that I'm working on in the background over here. So, all that being said, I appreciate you all tuning in. I appreciate you all coming by to see what I'm doing, but it's a Kenwood TL 922A 1350. Give me a call. We'll get you squared away. Gentlemen, I gotta go. Appreciate you all. Bump, bump. See ya. Bye.